Hey, good evening. This is Shelly, and I'm going to share my screen with you. And we are going to take a look at journal entry number 9, which is two-way ANOVAS. So thanks for joining me for this demonstration. I will share my screen with you. As you can see here, this is a data set that we've been working with quite a bit this semester. This is sleep.save. And this is pulled from Julie Pallant's SPSS Statistics Survival Manual, which has kind of been a mainstay for us this semester. So in this demo, I will discuss running a two-way ANOVA. But before I do that, for any of you that are just joining me and haven't been through this before, I'll quickly walk you through this SPSS screen, sleep.save. In our data view, you can see that these are the data set or data points from a survey from a rather large group of males and females, and it asks them various questions about their lifestyle and their sleeping habits. And then if we flip on over to the variable view, we can have a good idea of labels and just get an overview of how the data was measured. And by looking at the labels, we can just kind of get a general idea of what questions were asked and how people responded. But if you wanted specifics, you could go to the full-on questionnaire. So you would be able to see specifically how many people were questioned and what actual questions were asked in full. Excuse me. But a two-way ANOVA allows us to study the effects of two independent categorical variables on a dependent variable. So in this demo for Journal 9, we want to conduct a two-way ANOVA with post hoc tests, if necessary, to compare gender, means, sleepiness ratings for 3 provided age groups. So we're essentially adding gender mixed in with age. Our dependent variable is the sleepiness rating scale, and you can find it in this data set. It is labeled TOTSAS or TOTSAS. That's the label abbreviation. Our independent variables are gender. It's labeled sex in the data, and age, with age being broken down into 3 groups: 37 or less, 38 to 50, and 51 or more years old. Now we need to look at our 6 steps of hypothesis testing. Step 1, as you know, is to pick a test. This is easy in this case because it's already been selected for us. We were told we are doing a two-way ANOVA. We are doing a two-way ANOVA because we are adding another independent variable, gender and age, together instead of just one. So looking at variables, we have one dependent variable, which is our sleepiness total scale, and then 2 independent variables, gender, and we have 2 groups of gender, male and female, and then age, which is broken down into 3 levels, which we previously discussed. Next, we must check our assumptions. They are the same as for a one-way ANOVA. First, you must have a random sample. Secondly, they must be independent of observations. And 3, you must look at normality and homogeneity of variance. Our sample is robust, even though it doesn't reflect the entire human population. So that assumption is good. It has been met. Each survey participant answered the survey questions independently from each other, so we met that assumption as well. We can assume that a normal distribution because the sample is so robust. We could, however, run descriptive statistics, and we have learned that anytime we are running statistical analysis, that descriptive statistics is just a good habit to get in. And then as far as homogeneity of variance, the sample size is large and robust, so our assumption is met there as well. Step 3, we must now list our hypotheses. This time we will have 3 sets of hypotheses because we have to have a set for the gender, we have to have a set for the ages, and then we have to have a set for the interaction of the two. So your null hypothesis in each case is that they are all equal for each of the 3 categories. Your alternative hypotheses will be that they are not equal across the 3 different categories. Step 4 is to set the decision rules. Remember, we have to calculate F from the degrees of freedom, and then we have to go back to the chart in the back of the QWERTY book, another mainstay this semester. Remember that degrees of freedom is our n minus 1. To calculate F for the rows, gender, columns, ages, and then you have integration of the 2. So for rows, our degree of freedom is 1. The degree of freedoms for columns is 2. 3 minus 1. To figure your degree of freedom for the interaction, you multiply your degree of freedom of rows times the degree of freedom for columns. So 1 times 2, which is 2. So the degree of freedom for interaction is 2. It is necessary to remember this when we interpret our results. Step 5, we will go ahead and run the analysis. In the Palette book on page 283, you have step-by-step instructions of how to run the two-way ANOVA. I will briefly show you how to run the two-way ANOVA. However, I am not going to walk completely through it step by step because I have already done so, and it would just replicate the data I have already created. However, you would go to Analyze, and then you would go to General Linear Model. You would select Univariate. Once there, you would move dependent variables under the dependent variable category. As you can see right here, I have moved sleepy and associate sensations score, which is the total SAS. And then I moved the independent variables under the fixed factors. That is the age of 3 groups and sets. You must be careful because as you can see to the left, there is one simply called age. And then if you were to scroll down towards the bottom, there is one called age 3 groups, which you now see in my fixed factors box. You then would click over here to the right on options. You want to check descriptive statistics just because it's always a good habit to get into. We then check estimate of effect size, homogeneity test, and click continue. The air horn you hear in the background, on a side note, is a party they are having next door. I'm not inserting air horns into statistics. Then you are going to click into post hoc. We're going to go ahead and run it. At this point, we don't know if we will need it or not, but if you go ahead and run it, it'll do it for you. But we run post hoc, it needs to be on the variable that has at least 3 groups. And since looking at these variables, gender only has 2 groups, we can't do it on this. So it must be on the variable that has 3 or more, and that would be our age of 3 groups. So we're going to move our factor or our variable age 3 group over to the post hoc test for box. You would use this arrow. We also want to do a 2-key test on it, so we are going to check the box under equal variances assumed 2-key. Then we would hit continue. We are going to go to plots, and on the horizontal axis, we would move the variable that has the most groups. So that would be age 3 group, because remember, the gender or sex only has 2. Then on separate lines, you would move the other variable, which would be sex or gender. Since I had done this previously, once you click add next to plots, you would see the variables you had listed. So you would see that it says age 3 group asterisk sex. And then you would click OK or continue rather, and see this error message comes up because we had previously done it. And then you would click OK. But I'm going to X out of here because, like I said, I had already done it. And then I'm going to go down to the data screen, which I had already previously done. So as you can see at the top, this data screen is labeled the univariate analysis of variance. And finally, step 6 in this process is to interpret our results. So first, let's take a look at our descriptive statistics. Before we do that, let's go ahead and look at our between subjects factors. Notice we have our variable of age 3 groups. Remember, we said we had our group that was less than or equal to 37 years of age. We had a group that was 38 to 50 years old, and then we had a group that was 51 plus years of age. And you'll notice our N, or our size for each of these, 79, 79, and 72. And then you can look at our sex. We had 0 for females, 1 for males. We had 140 and 90. So now we'll go on to our descriptive statistics. You can see that they are broken down by age of 3 groups and then sex, female, male, and total. You can see a mean and a standard deviation as well as our N number for both. Our total number was 230. You can see 230 right here at the bottom. I'll move my cursor over here. So let's go ahead and set that number aside. On Levine's test of equality of error variances, we were interested in significant levels, and we want our levels to be greater than 0.05. Please be patient. I'm using a touchpad mouse on my computer because I actually don't have my wireless mouse with me. So we're hobbling through this a bit. As I said, Levine's test was interested in significance levels, and we want the level to be greater than 0.05. So we scroll to the Levine's chart for the Levine's test, and we make sure that we look under the column that says sig for significance. So that would be this column right here to the far right, and we notice that all 4 of these are greater than 0.05, so we're good to go there. That means that variance is not significant. Now we're going to check for the interaction effects. So between age and sex, we look at significance column on the age sex row. That's when they're combined. So we're going to come down here to the age 3 group sex and look at the significance column over here. We just kind of scroll over, and we see that our value is 0.568. If it's less than or equal to 0.05, there is a significant interaction effect. It is greater than 0.05. There's no significant interaction effect between age and sex. But now we have to look at each variable separately. So let's look at the age by itself. And the significance is 0.181. You'll see right here. That's still greater than 0.05, so there's no significant effect there. And now let's look at sex, which is 0.003. So it is less than 0.05, so there is an effect there. There's no significant effect for age, but there is for sex or gender. Now the effect size for age, we can tell that there is a small effect size by looking at the partial eta squared column. So let's go down to age right here in the partial eta squared. And you'll see, you can see these various scores. We see that the biggest one is this intercept score. But looking right here, according to Cohen, if we're looking at this age of 0.015, that is a very small effect size. We don't necessarily need to run a post hoc test, but since it's here, we might as well look at it. And we might need to find where the differences occur with gender, and we can look at multiple comparison charts at all the significant levels, checking to see which are higher than 0.05. Here they are all higher than 0.05. Let me scroll down for you. You can see that they're all higher than 0.05. So finally, we've got to see if we're going to reject our null hypothesis or fail to reject it. So we need to figure out our F scores. And remember, we used that earlier. We looked at the chart in the back of the QWERTY book and with our degrees of freedom. Our critical value for rows on the chart. We do this by finding the intersection of 1 and 224. Because 224, we got our total number was 230, which we found if you looked in our descriptive statistics. We mentioned remembering 230 because we would need it later. So we subtract our total degree of freedom of within, which was 6. It was the rows times columns, so 2 times 3 equals 6. And 230 minus 6 equals 224. And looking at our chart for row, we look at the intersection of 1 and 224, and that gives us 3.888. And the critical value for columns using the same method is 3.041. And then the critical value for interaction is also like column 2, the intersection of 2 and 224, and that is 3.041. So using that information and looking at our F values, for the row hypothesis, our value is 9.106. Just scroll back up here for just a second. Our F value, you can see right here, 9.106. And if anything is greater than or equal to 3.88 based on the number from the chart, we reject the null hypothesis. So we're going to reject the null hypothesis on rows. For columns, anything greater than or equal to 3.014, we reject the null. And our number is 1.722. So we're going to fail to reject the columns, the age. And then the interaction, anything greater than or equal to 3.041, we will fail to reject the null. I remember that the number was 0.566. So it is less than 3.041, and we failed to reject the null. And this concludes our demonstration on the two-way ANOVA and its interpretation for Module 9. Thank you for joining me, and until next time, have a great evening.